Hello students. So now we are going to do the lab experiment on the verification of reciprocity theorem. So before going into the tinkering of the circuit, let's first discuss the theory of the reciprocity. So after performing this experiment, you should be able to know the application of this reciprocity theorem because this is very much applicable to the antenna and transmitter receiver systems. And the second thing that you must be able to understand is when a circuit is said to be a reciprocal. So let's take an example that if I have any number, let's say 2, what will be its reciprocal? So it will be equal to 1 upon 2. So from this thing, you can understand a reciprocal theorem like if you are applying a voltage source in branch 1, let's say this is branch 1 and this is branch 2 and this is branch 3. So the current here, let's say, is I3, this one is I2, and here it is your I1 current. So if this voltage that is applied in branch 1 is giving us a response as I3 in branch 3, then if I am going to interchange my this one to here and this current source to the voltage side, then again the current that will be produced will be same. For example, if I am getting the ratio V upon I3 as some constant here, let's say K. So now in the second circuit, what I am going to do is I'm going to put my milliammeter here, and then I am only going to, I have just replaced my voltage and milliammeter. I have interchanged their position, and now I have put the voltage source in place of the milliammeter. So now my voltage source is in branch 3 while my milliammeter is in branch 1. So now the value of, again the value of this V by I1 will again be equal to K. So these two values will be equal. So whenever any circuit that gives me the ratio of V upon I3 and V upon I1, when the values of milliammeter and voltage are interchanged and still the ratio is coming out to be equal, then we say that the circuit, that reciprocity theorem is applicable to that circuit. So now here we are going to take the circuit in which a 10 volts voltage source we are going to take in the TINKERCAD. Here I have taken R1 as equals to 50. This is also 50 and this one is 100. So why I have taken R1 here as 50, why I have written only R1 here, because we are going to take 3 cases and we are going to change the value of our this R1. Firstly, we have taken it as 50, then we are going to take as 75, and in case 3, we are going to take it as 100 ohms. And then we are going to analyze the value of this I3 and the ratio of with this voltage. So here I have just carried out a small calculation because we require the value of this I3. So firstly, I have calculated this whole RT. So 50 and 100 both are in parallel and then in series with this R1. That gives me a total voltage of total resistance of 80.33. When divided with the voltage, it gave me a value of 0.12 amperes. So by applying the current division rule, I have come out, because this 0.12 is the value of current till here, and then it got divided between two branches of 100 ohm and 50 ohms. So I applied the current division rule and got the value as 80 milliamperes. So now what we are going to do is we are going to interchange the value of our this voltage source and the current where we have measured it, both branches we are going to interchange. So here it is 50, here again is 50, then 100, then this is my 10 volts. And now I am going to measure I1. So as you can see that the circuit is same, the value of these resistance remains same. So then again, when you are going to calculate and you are going to see that the value of our this current will again be coming out to be equal to 80 milliamperes, because we have taken this as both 50 ohms. So now we are going to change the value of R1, and now I am going to make it as 75 ohms, and then we are going to do the calculations now. So now we have taken the second resistance as R1, 75 ohms, and now we are going to calculate the value of this I3 here. So here the total RT will be equal to the parallel combination of 50 and 100, and then in series with 75 ohm. So this is going to give me the value as 108.33 ohms. So now the total value of IT current that will be coming will be 108.33, and that is going to give me the value of current as 0.092 amperes. So now this is the value of current that is coming till here. Now because it is getting divided into two parts, and we require the value that is going into the 50 ohms. So total current IT, that is 0.092 multiplied by opposite branch resistance divided by the sum of the two resistances in which the current is getting divided. So this value is going to come out to be, so this is 100 by 150, coming out to be 0.06 amperes. So now let's change the position of our this 10 volts and our this I3 here. So after interchanging the value, the circuit that we are going to get is like this. And now we are going to find the current I1, let's say here, or I should name it as I3 dash. So here it is 75 ohms, 50 ohms, 100 ohms, and here the value is 10 volts. So now I am going to go with the calculations of our this circuit and find out the value of I3. So now the total resistance RT will be equal to 50 will be in series with the parallel combination of 75 and 100. And here I will be getting 50 plus 42.85. That is going to give me the value 92.85 ohms. So the next step is to calculate the total current IT that is coming here. So that will be total voltage divided by the total resistance, and that is going to come out to be 0.107 amperes. So the last step is to calculate the value of I3 dash using your current division rule. So I3 dash will be equal to again this IT total current multiplied by, that is point, that is 0.107 multiplied by opposite branch resistance divided by the sum of the two resistances in which the current is getting divided. So this is going to give me the value as 0.06 amperes. And here you can check that the value in the previous case was also the same, and here it is also the same. So this was all about our case 2. So now we are going to switch over to our case 3, where you are going to change the value of this 75 ohm to 100 ohms resistance. So this is your case 3. So you are going to take three values. One was 50 ohms and then 75, and then it is 100 ohms. So now again we are going to check out the values here. So here I'm just changing the values in our this calculation only. So this is going to give me 100 plus 50 in parallel with 100. So again is this thing will be 100, and this is going to give me 133. Let me just rub and write it here. So it is going to give me the value 133.33 ohms. So here again it will change to 133.33. that is going to give me the value of current as 0.75 amperes. That is the value of total current. So in the next step we are going to get the value of I3, and that is coming out to be 0.5 amperes, right? So now in the second step, we have changed the value of position of this 10 volts here. And now we are going to have our, instead of this 75, we have got our 100 ohm resistance. So I'm going to put 100 here. So 100 in parallel with 100 will give me a value of 50 ohms. That is going to give me the final resistance as total 100 ohms. So here the total current will be equal to 10 divided by 100, and that will be equal to 0.1 amperes. And now you can see that this 0.1 amperes is going to get divided into two equal resistances of 100 ohms each. So that is nothing, but you have to divide 0.1 in half. So half will go to this 100 and half will go to this 100. So what I'm going to do here is I'm going to get the value of my this I3 dash as 0.1 by 2, that is coming out to be 0.05. And you can see here that this is same as the value we just got in the previous case. So all these values verify the reciprocity theorem. So let's don't waste time and go to TinkerCAD to verify all of this findings. So now using TinkerCAD, I have taken this as the R1 value of the this resistance. Then this is my 100 ohm resistance, and this is my 50 ohm resistance in which we have to measure the current I3. So what I have done is I have adjusted the multimeter in I3 branch so that we can know the value of the current. The voltage value taken here is 10. So now I am going to start the simulation to know the value of this current. So this is coming out to be 100 milliamperes. So now I am going to just shift my this milliammeter towards the I1 position and shift my this power supply towards this position and find out the value of the current. Or we can take the different values of this resistance R1 and we can check out the values here, and then we are going to one by one, because when we are going to change the connections, then we can take the reciprocal of all these three circuits. So let's take the case 2 here, and I am going to change this 50 ohms to 75 ohms, and then I'm going to cross check the value of my current here, and I'm going to tabulate the values. So the value coming here is for 75 ohm of R1 as 80 milliamperes. So the last step I am going to do is I'm going to again vary my this value of this resistance as 100 ohms and calculate the value of the current coming. So the value of the current that is coming is for R1 equals to 100 ohms is coming out to be 66.7 milliamperes. So now I am going to change the connections, and I'm again going to vary just like this so that we can have all the three values of the current. So that will be less cumbersome. Now I have changed the connection. I have taken this as my I1 branch resistance, that R1 I am going to vary the values. So the very first value I have taken is as 50 ohms, and now I am going to start the simulations to know the value of the current, and it is coming out to be 100 milliamperes. That is the same as we discussed in the previous case. Here you can see that I have fixed this value as 50 ohms. I am not going to vary this value as in the previous case. So now I am going to stop the simulation, and I am going to vary the value of my this resistance to 75 ohms. And if you all remember, the value coming out in the previous case, that is the case 2, was coming out to be 80 milliamperes. So here again it is 80 milliamperes, and the last step is to change the value of our this resistance to 100 ohms. So here making it to be 100 ohms, and the previous value was 66.7, and here again you can see that the value is coming out to be 66.7 milliamperes. So hence you can see that reciprocity theorem has been verified for this given circuit for different values of R1. So that's all for now. Thank you so much for watching.